Okay, so let's consider this example here. We're looking at f of x equals x minus 3x sine of x. We want to find any zeros that, or this zero, I'm telling you that it's only one, that falls between pi over 2 and pi. Pi over 2 and pi. So we want to find the zero using Newton's method that falls between pi over 2 and pi. So the process we begin is, hey, we have to find the derivative to use it. So that would be the derivative of x, which is 1. Then we have 3x sine x. We're going to have to use the product rule. So the derivative of 3x is 3 times sine x. So I did derivative of the first times the derivative of the second. And then the first, 3x times the derivative of the second, which is cosine. So that's my derivative. And now we need to make an initial guess. And we're just going to use technology here rather than having to type this stuff in over and over again. So I'm going to make an initial guess here of 2. So I'm going to store 2 in for x. And then the expression I'm going to type into my calculator would be in terms of x now. It's going to be x minus f of x over f prime of x. So x minus 3x sine x, all divided by the quantity 1 minus 3 sine x minus 3x cosine x. And that's going to get stored into x. That's going to get stored into x. Okay, and then we're going to go to our calculator and start doing that. And I picked 2 because I need something between pi over 2 and pi. Pi over 2 is about 1.57. Pi is 3.14, so 2 is kind of the only whole number really that's in between those other than 3. So I'm going to try 2 as my guess. And so go into my technology here, and I'll put 2 in as my initial guess. Again, the way I have to do it on this calculator. And then I have to type in that whole expression in terms of the variable last instead of x, which is what you can do on your calculator. So last minus 3 times last times sine of last. All that divided by 1 minus 3 times sine of last minus 3 times last times cosine of last. And I run into a problem. The first answer jumps way out of my interval. And I can keep computing that and see, well, maybe it'll fix itself. And no, it goes 6.62. And then I do it again, and I get 6.623. And do it again, and I get 6.62302216. It's awful close to what it was. So this is leveling in on another 0. So my guess is actually taking me to another 0, but that 0 is outside my interval. That's actually bigger than 2 pi. So this thing has actually lots of zeros. I'll show you the graph at the end here. So we need to refine our guess, and I'm going to try something else. So 2 didn't work, so you can maybe try 3, or I'm going to try 2.5. Or maybe you might want to try 3 as my initial guess. So I'm going to put that as my initial guess. Again, if you were doing this on a graphing calculator, you do 2.5, store to x. And then you can use, you don't have to retype everything, because you can use in your graphing calculator the second enter to kind of go back and cycle through old stuff that you typed in. So I don't have to type it in again. So on my calculator here, I can just go back and click it. Just click onto it to pull it back up. And let's see if this gets us a little bit closer to that 0 that's in between pi over 2 and pi. First guess, that seems kind of good, 2.88. Let's see when we compute the next one, 2.80. That's looking pretty good. Let's see if it levels off. So 2.801. See, the digits are getting closer. It was 804. Now it's 801. Let's keep computing until it really just basically levels off on my calculator. I had 176. Now I have 175. So again, still leveling off slowly. Now I have 1755. It was 4415. Now mine says 4414. I'm guessing mine's probably not going to go any further, and it doesn't. So here I have my 0, 2.80. Let's round off and say 18. 2.8018, rounding off to 4 decimal places. And usually the directions will be clear on how much you need to round here. So that's the idea behind Newton's method and how you can use technology to kind of speed it up. You do have to be careful with values anytime the derivative is zero. If you follow along in your textbook, there are times where there are examples where it's just going to keep bouncing back and forth between two values and it'll never actually reach the actual zero value. There are drawbacks like that that can sometimes happen. And those are just things you have to be aware of. That usually just changing the guess can help you maybe get a better estimate of that. So that's Newton's method and how it works. Pretty short idea. You just kind of have to understand and be able to work with it.